Hello everyone, my name is Meenal Swami. Today we are going to study the practicals of digital electronics. Because of this pandemic situation, we are unable to perform our practical in the college, as the digital electronics practical require a digital trainer kit, which is a hardware. So, to manage this situation, we are going to perform the practical on this virtual trainer kit. As the first assignment from the digital electronics and logic design syllabus is the full adder, today we are going to study how to perform the practical of full adder on this simulation software. So the full adder, the theory part of full adder we have already gone through, which tells us that the Boolean expression of full adder is the sum is equals to A XOR B XOR C. After looking at the expression, we come to know that we need to perform XOR operation. To perform the XOR operation, we need a XOR IC. On this digital trainer kit, we need to add the XOR IC, which is 8074886. So let's add that 7486 IC. The IC pin structure is first pin and second pin are input, while third pin is output. The 7486, which is a XOR IC, is a total 14 pin is having a 14 pin structure. So 7 is ground, while 14th pin is VCC. This is like 1, 2, 3, 4, 5, 6, 7. Then this 14 pin is actual the 8th pin of the IC. So 7 is ground and 14th pin is VCC. So 1, 2 are input, 3rd pin is output, 4, 5 are input, 6th pin is output. The structure of the IC is first and second are input, third one is output. On this circuit, first we'll connect this 7 pin to the ground and 14 pin to the VCC. Now we have to decide the inputs. This part is the input part, while upper part is the output section. So the A, we will decide this 0 as A, this is B and this is C. So let's perform XOR operation. A XOR B. This is half adder. A XOR B. Now this third pin is output. Let's make it as an input because we need to perform 3-bit operation. A XOR B, and this is A XOR B, which has again made as an input. So this one is a C. So now it has become A XOR B XOR C. Let's connect this to the output. After doing this all connection, we can power on the circuit. So the power is being given to our IC. Now we need to validate the connections using truth table. After looking at the truth table, we can say that when there is an odd number of input, there is a sum is equals to 1. So let's make an odd number of input. See, the output is, the sum is equals to 1. Let's make an odd number of input. The sum is equals to 1. then if we make the input even, the sum is equals to 0. So what we have learned from this experiment is the full adder equation is sum is equals to A XOR B XOR C, and the truth table of the full adder sum is whenever there is an odd number of input, we get a sum is equals to 1. Now we will go for the second part of this, that is carry. Whenever we perform a full adder, we get a two output, that is sum and carry. Sum we have already performed. Now we will perform carry. So the carry equation is carry is equals to A and B or C into the bracket A XOR B. Either you can perform like this, or you can perform the carry as carry is equals to AB plus BC plus AC. Whichever you are interested to do so, you can go with that. So if you want to perform AB plus BC plus AC, then we need two more ICs. One IC as a AND to perform the AND operation, that is 7408. So let's take that. One more IC we require to perform OR operation, 7432, which is a OR IC. As we have already decided, this is our A, this is our B, this is our C. Now let's perform the practical to implement the equation of carry. So the carry equation is, first we will perform A and B. So the AND IC is 7408. Whenever we attach an IC to the IC slot or mount an IC to the IC slot, first we should do these two important connections. For the both of the ICs, same pattern has been followed. So the pattern is AB, first and second are input, third one is output, 4, 5 input, 6th pin is output, 19, 18 input, 17 is output, 16, 15 input, 14 is a output. I have just mentioned the number on this board, but at actual this is total 14 pin structure. So first we will implement A and B operation, that is AB. So this pin should be connected to A, this pin should be connected to B. This is the third input is AB. So let's connect it to the OR gate, because we want to perform at the end OR operation of AB plus BC. So again let's connect this as BC. So this is our B, and this should be connected to C. 6 is our output of BC, which should be connected to our OR IC. Here we have performed AB plus BC. So this is the third pin is output of AB plus BC. So let's make an input. So we have made this as an input again. Now we left with the AC. So let's do that as well. A and C. This is an input to the OR gate. Finally, this is our carry. Now let's validate with the help of truth table. As we have seen, the sum is there whenever there is an odd number of input. Now the carry is whenever the input is 0, 1, 1, we get a carry. So 0, let's power on the connections. So this is 0 and 1, 1. Look at here, we got the carry as a output. We get a carry as an output whenever there is an input as 101. Look at here, we got the output. We get a carry as an output when 110 as an input. We got the output as carry is equals to 1. Whenever all of them are 1, the sum and carry both are equal to 1, 1. So that's all for the today's practical. We have successfully implemented full adder using basic gate and with the help of simulation software. Thank you so much for watching the video.